Okay, we don't really review a lot for testing here. I have to assume that you're going to get it going and do what you got to do. I was looking at a note I had in my book here. Now, what we're going to talk about today is scientific notation. That's 2.5, and basically there's two things we need to understand today, and that is the scientific notation and standard form. Okay, those are two ways that we're going to put numbers today. Okay, standard form you already know. Okay, standard form is simply 3,292,565,000. That's standard form. Okay, what we're going to talk about today is how we take a number from standard form to scientific notation, and from scientific notation back to standard form. Okay, let's remember what scientific notation looks like. Scientific notation is going to look like that right there, 1.6 times 10 to the 12th power. Okay, basically what you're doing is scientific notation is a way to express very large numbers in a smaller, more easier way to manipulate them. Okay, for example, if I had this number, if I had 1.92 times 10 to the 28th power, okay, well, 1.92 times 10 to the 28th power, okay, is 192 with 26 zeros after it. Okay, so obviously you would not want to write when you're dealing with large numbers and you're going, well, when does anybody ever deal with those type of large numbers? Okay, good place to start is in the solar system. Okay, scientists that deal with the solar system, or whoever deals with the solar system, it is scientists, but there are, I'm sure, other professions, other careers that deal with the solar system. You have to be able to manipulate numbers, and if I'm having to write out that number and numbers just like it all the time, then that's going to take forever. Okay, so one of the reasons it's called scientific notation is because scientists came up with an easier way to write numbers, and eventually you will manipulate numbers like this. Okay, what I mean by that is you will multiply them, you will divide them, you will add them, you will subtract them. Okay, so we're learning the basis of, I know we'll do this in Algebra 1 this year in 8th grade, because I've taught the lessons before. Okay, and so I know that we have two lessons in that book on manipulating and using scientific notation to help us find distances, things of that nature. Anybody remember how many miles a light year is? What? Tristan? No. No. I'm going to have to talk to Miss Comerford, I see. It is 600 trillion miles. 600 trillion miles is a light year. Okay? So if we're just thinking in terms of just one light year, okay, one light year is 600 trillion. So let me see if I can even write that properly. See, it's one more, it's millions, 100 millions, billions, so I got to go one more set. Okay, so that's 600 trillion, 100,000, millions, billions, trillions. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how I would write that is 6 times 10 to the 14th power. Okay? So that is 600 trillion. Okay? The furthest star that we know about is 13.2 billion light years away. Okay? Not 13.2 billion miles, but 13.2 billion light years away. Okay? That's pretty far. It's a little shot to get there. Okay? Well, we know then that 13.2 billion, okay, is 13 billion 200 million. So if I write that, yeah, it's a 2. It's a fast 2. Okay, if I write that, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 1.32 times 10 to the, did I say 10? 10 power? To the 10th power. So, to figure out how many miles that actually is, okay, to figure out how many miles that actually is, all I have to do then is this. Take 6, let me move it down, that's too close. Take 1.32 times 6, and that's going to be 2, carry my 1, 19, carry my 1, 792. I have 2 decimals, so 7.92 times, I simply take the 14 and the 10 and add them together. So it's 7.92 times 10 to the 24th power. Okay, so basically this, 792, okay, with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's the furthest star. So if we even look at that, there's our groups of 3. Wow, there's so many zeros there, I'm getting confused. I'll move out of your way just a second, Erica. That's what it looks like. Okay? So, we got this right here. That's hundreds, 100,000ths, 100 millionths, 100 billionths, 100 trillionths, 100 zillions. Don't know, don't care. Okay? That's a long way away. So you can imagine having to manipulate numbers if I wouldn't have had scientific notation. Now, obviously, I'm not expecting you to know how to do this part today. Okay? What we're talking about is taking these numbers and changing them into scientific notation or the other way around. Here's how we're going to do that. Let's look at an example. I'm going to take, for example, let's take 29 billion 200 million. Make sure I read that right. Yeah. No, 29 million. Whoops, change colors. 29 million 200,000. Okay? Now, before I get there, can you imagine, let's go back to this, the 7 whatever, okay, 7.92 times 10 to the 24th power. Just, think about it. It's hard to even fathom, without seeing a number like that, it's hard to even fathom, the Lord's creation. And that's just as far as we can see, okay? That's as far as, humanly possible with the things that we have, everything that we have, telescopes, all the other things, satellites, that's pretty daggum big. Okay? So, it just amazes me, that just brings to me just all these things, how God has put everything here in this solar system, on this planet. The fact that you can, I can pick up my cell phone and call Russia. And, you talk back and forth and there's no delay, there's no nothing. Just all the things that it just amazes me. So if nothing else, we can use scientific notation to understand the enormity, the expansiveness of God's creation. Okay? And I don't even know, I can't even fathom that number. Okay? I really can't. There's larger numbers than that, obviously. Okay? We figured, I think may have been, it was 2 years ago, we figured the probability of the Big Bang theory actually happening. And I'll show it to you one day, but I've got a picture, I got a paper of the number of zeros it would take. And it was like, I think if I remember right, it was like 42 pages of zeros. So it was like 1 times 10 to the 42nd power, or no, it was more than that, because there was 42 pages of zeros, not 42 zeros, but like 42 pages of zeros. So I went into Word and I just started making zeros, and it ended up being 42 pages. And I'll have to show it to you when we get to the probability stuff later on in the year, but just that expansiveness, and that's why we need scientific notation, okay, to deal with numbers. Now, this number obviously is not that big, okay? When you get into algebra, calculus, pre-cal, things like that, your number's obviously going to be larger. When you get if you're into science and you get into the science field, obviously you're going to deal with numbers that are a lot larger than 29,200,000. But for our purposes, let's see how we do it. Your first step to change it to scientific notation is move the decimal in the number between the first two digits. Oops. Okay. Move the decimal now. So where's the decimal in this number? Well, it doesn't have one, so we have to put one. We always put it at the end. So what I'm going to do is I'm going to take that decimal and I'm going to move it between the first two digits. And I'm going to put it right there. So my new number is 2.9. Okay, now, this number that you create must always fall between 1 and 10. Okay? In other words, I can't move the decimal to here, to there, any of those other numbers. Because if I do, the number's not going to be between 1 and 10. Okay? Joshua? Huh? Oh, yeah, thank you. Yeah, thank you. Yes, it should be. I forgot I had another 2 there. Should be that right there. Okay? Is 2.92 in between 1 and 10? Is it? Yes, it is. Okay? 2.92 is between 1 and 10. So that first step is met. Now, the second step. The second step is to multiply the number in step 1 by a power of 10. So I'm going to take 2.92 and multiply it by a power of 10. Okay? Now, our exponent on the power of 10 is equal to, whoops, there. Okay? Our exponent on the power of 10 is equal to the number of times you move the decimal. So, if I come back up here to our problem where I actually moved the decimal, okay, I moved it once, 2, 3, 4, 5, 6, 7 places. So then my number on my exponent is 7. So my actual answer is 2.92 times 10 to the 7th power. Okay? And that's going from standard form to scientific notation. How I got to 7 was how many digits that I moved the decimal. I moved it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. Okay? All right, let's do another one without all the writing. Okay? Not yet. All right. Let's do this one. 90 billion, I think. Yeah, 90 billion. So 90 billion. Okay? So, I'm going to move the decimal. There is no decimal in this problem, so I'm going to place one in the problem. So I'm going to place it right here, and now I'm going to move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. So I'm going to move it to right there. Okay? So that makes 9. Now, don't do this. Okay? That sort of defeats the purpose if I'm just going to rewrite all the zeros. Okay? Don't do that. That's wrong. Okay? It's just 9. Okay? So it would be 9 times 10 to the 10th power. Okay? And that's your answer. All right, let's look at one that has a decimal in it. Let's say I had this. Let's say I had 10,920.52. Now, this is a pretty weird one because it's not really going to help you much to write it in scientific notation. Okay, but I want to show you how you would do it if they told you to write one like this in scientific notation. Process is still the same. There's the decimal 4 times. So here's where you would have a harder time. I have to take 1.092052. Okay? So realistically, it didn't really help me. I still got to write the whole number. Okay? But if there's any what they call significant digits, okay, behind the decimal, then you have to put them. Okay? Significant digit means 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay? If they're just all zeros behind the decimal, you don't have to put those, obviously. Okay? So this would be times 10 to the 4th power. Okay? And eventually this year we'll start dealing with negative exponents, okay, and dealing with decimal numbers that we have to change to scientific notation. But I'm going to check to make sure, but I don't believe we don't have any of those in this one. In this lesson, I think it's later, and I can't remember the chapter, but I think we cover them later if I remember right. All right, now, so that's scientific notation to standard form, or standard form to scientific notation. Let's look at going from scientific notation to standard form. Okay? So that one we just did was standard form to scientific notation. This is the other way. Okay? For example, if I have 802 times 10 to the 7th power. 3.5802 times 10 to the 7th power. Okay? So that means I've got to change it to standard form. It's very simplistic how to do it. You simply do this. There's the 7. Okay? I am going to take in my decimal number here, and I'm going to take my decimal and move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. And so where there is no digit, I must put zeros. And so that's going to give me $35,802,000. Okay? So that's taking 3.5802 times 10 to the 7th power. Okay? So I want you to do number 27. Oh, no, hang on. Do number 28. Do number 28 in your book. All right, it said 4.0. Nope. Okay, said that right there. So I got to move it 6 places. Okay, and I got to move it 6 places to the right. So that means once, twice, 3 times, 4 times, 5 times, 6 times. So that's 4, 4, 0, 0, 4, 4, 0. Okay, because I moved that 0 one last place. So it'd be 4,400,440. Okay, 4,400,440. All right. Now, let's look at this. 8.12 times 10 to the 15th power, and then they give me 1.5 times 10 to the 17th power. And we got to see which one's greater. Okay? Now, very simple. If I take the decimal right here in 8.12 and I move it 2 places, that leaves me with how many left out of the 15? So 13. So this one's going to have 812 with 13 zeros after it. Okay, so that's a total of how many digits? 16, right? So 3 here, 13 more would be 16 digits. Well, this one right here is going to have 1. So 16 zeros after it. It's going to have 18 digits. So 18 digits is always going to be more than 16 digits. Okay. Now, here, bless you. Bottom line is this. This number here and this number here. The larger exponent's always going to be the larger number. Okay? I mean, that's just pretty simplistic stuff. You just go here. Okay? So, not really anything. If you need to figure it out to try to do it, then you're more than welcome to do that. Now, the other way they're going to do it is this way. They're going to take 548 million, okay, And then they're going to say, okay, 5.48 times 10 to the 7th. Okay, well, all we have to do is this. Convert the 548 million to scientific notation. Well, that's once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. So that's 5.48 times 10 to the 8th. Well, obviously then, which one is larger, 5.48 times 10 to the 8th or 5.48 times 10 to the 7th? 10 to the 8th. Okay, so it's greater than sign. Okay, not real hard. Fairly simplistic. All right. I'm looking at a light year problem. All right. So here's what you're going to do, your work. Now, understand this, because I want to do this, and then we'll talk about, make sure everybody's clear on what's going to be on the test. This is due on Thursday, okay? But let's see, we got 2.5, and we're going to go 11 through 39. Now, most of them are, they're fairly simplistic. Write the original problem, then put it in scientific notation. Shouldn't take you a whole lot of time. Now, this is due Thursday. Okay? So when you choose to do it, you want to do it tonight, that's fine. Do it this afternoon during one of your classes that you have time in. Whatever, that's up to you. Okay? Now, your test. Let's talk a little bit more about that. Your test tomorrow will cover, let me get the actual sections, because I know we skipped a couple of sections. All right. I can't remember if we covered that. Let me look. That's why I have this. Yeah, okay. Your test tomorrow will cover 1.3, 1.4, 1.5, 1.6, 1.7. Okay? So, then the test tomorrow will cover 1.3 through 1.7. Okay? Nothing from Chapter 2. Okay? 1.3 is powers and exponents. 1.4, I believe, is order of operation. 1.5 is equations and mental math. 1.6, perimeter and area. And then 1.7, problem solving. Okay, so that's what it'll be over. There'll be some bonus questions that probably I'll put on there from 1.1, 1.2, but you should know how to do it. 1.1 was patterns, 1.2 was filling in. You have m minus x, and you put in values for the variables. Okay, so that will be tomorrow. Okay, it'll probably be about 25 to 30 questions. Obviously, it will show all your work on the test, and I think you should do fairly well on it. It won't be that hard. Just make sure that you do study for it this evening. Okay. So, any questions over what's on the test tomorrow? Thursday we will cover 2.3 and 2.4, which is multiplying and dividing decimals. Okay, I wanted to go ahead and cover scientific notation today because I knew it would take the longest of those ones that we did. All right, we ain't got a whole lot of time left, so we'll end that for